Let's look at how we express enthalpy for a chemical reaction. An example of an exothermic chemical reaction is the combustion of methane. 1 mole of methane reacts with 2 moles of oxygen to produce 1 mole of carbon dioxide, 2 moles of water, and 891 kilojoules of heat. We know from our everyday experience that burning is an exothermic reaction which releases or produces heat. We can write the heat as a product of the balanced chemical equation, but what is more common is to express the heat flow as a change in enthalpy, or delta capital H. The enthalpy for this reaction has a negative sign, and notice that per mole is written. This might be a tad confusing because the chemical is not specified. This means per mole of methane. The amount of chemicals matter. If we double the amount of methane that combusts to 2 moles, then we double the amount of heat that is produced. If we triple the amount of methane that combusts to 3 moles, then the amount of heat produced is tripled. We know from our everyday experience that if we increase the amount of matter that burns, more heat is generated. We wouldn't try to heat a house by burning a piece of paper or a twig. Here's an example of an endothermic reaction. 1 mole of nitrogen reacts with 1 mole of oxygen and requires 180 kilojoules to produce 2 moles of nitrogen monoxide. Again, we can write the heat as a reactant in this balanced chemical equation, but it is more common to express the heat as enthalpy, or delta capital H. The sign of enthalpy is positive since heat is absorbed or required for this reaction to occur.